Okay, so hello everyone. So let me discuss this next topic for our final term. Okay, so let's start with an example problem. So we are given a beam, okay, and it has a pin support, and then a roller support. But it does not end at the roller support. It extends, okay, more, and then it is connected at the right end with a fixed support. Okay, so meron tayong tatlong supports. Okay, so we have a pin, a roller, and a fix. So if we will analyze this one, so the number of unknowns that we have is we have 4 pin, we have a vertical, a horizontal reaction. For the roller we have a uh, one reaction. In this case, it is vertical. Okay, and then for a fix, we have a vertical, a horizontal, and a moment. So if we will try to determine, we have 1, 2, 3, 4, 5, and 6 unknowns. Okay, so for these two span beams, so it is two span, no? Since yung mga supports na ginamit nila, you have 6 unknowns. Okay, using our usual methods in solving reactions, we have equations of equilibrium. The equations of equilibrium are only limited to summation fx, summation fy, and summation moment. So we have 3 equations, 6 unknowns. This cannot be solved by the usual methods using equations of equilibrium. Okay, so to find the support reaction at the supports, we will use what we call the methods in analyzing indeterminate beams. So this beam is called an indeterminate beam. Indeterminate beam, ibig sabihin, it cannot be solved using equations of equilibrium. Okay, so these are the usual methods, the classical way. Okay, so we have the moment distribution method, the slope deflection method, the force method, and matrix structural analysis. Okay, so we will only focus on moment distribution method. Okay, so we will learn today how to solve the reactions of this beam using moment distribution method. Okay, so how do we do that? Okay, so first, I have prepared a table here. Okay, so in this table, it contains the following information. So you have uh, the joints, okay, okay, and row 2 we have the members, and then row 3 is what we call moment of inertia, and then L row means the length of the given member, then you have K, this means the stiffness of the member, and then DF, okay, that stands for distribution factor, and then FEM stands for fixed end moments, Okay, and then we have first distribution carry over and second distribution carry over moment until we reach the fifth distribution line and then final moment. So we will discuss every element in this table. Okay, so how do we divide this table? So let me erase this one. Okay, so first gagawin natin is we give the members a name. Okay, so let's differentiate. Okay, so for the joints, these are the connection points in our beam. Okay, let's have joint A. At joint A, you have a pin, and then at the pin, this member is connected. Okay, so let's call that joint A. Yun yung connection point ng pin and ng una nating member. And at joint B, there is a roller na connected sa joint B, and then connected yung part na to, this part, and then this part also. Okay, and then at joint C, it is connected with a fixed support and this member right here. Okay, so yung connection points lang nila yung titingnan natin. So the joints are the connection points. So usually they are in the place or in the positions of the supports. Those are usually, yun yung usual locations ng mga joints natin kung saan din yung mga supports. Okay, so we have 3 supports, 3 joints. Okay, for every joint, there is a member connected. At joint A, yun nga, yung member na to. Okay, so let's just give this a name. Since this member is spanning from point A to point B, okay, so let's call this joint AB, member AB, I mean, it is connected with joint A. And then at joint B, the members that are connected with joint B are member BA, okay, which is this one, which is the same as AB, but we give it a different name para hindi tayo malito na yung AB, no, it is connected with A, and then BA is what is connected with B. Okay, although they are the same member talaga. Okay, so we're just trying to identify kung saan siya malapit. Okay, so for example, ito, it is, kaya naglagay ako ng ganito para hindi tayo malito sa naming, is malapit sa joint A is ito, and then we give it the next one is B. Okay, malapit sa joint B is siyempre si B, so we give it a name of BA. Okay, so ganun lang naman. If ayaw mo yun, you can use other names. Okay, so joint B, okay, so BA is connected on the left side of joint B. Ito yung joint B. And at the right side is member BC. Okay? And then at joint C, connected yung member CB, which is the same, basically the same as BC, but we just gave it a alternative name. Now we're following what is the nearest to the joint. Okay? And then I. So let me go to our presentation right here. Okay? So what is I? Okay, so I is the moment of inertia. So this part indicates the moment of inertia. Okay, so it is one of the geometrical property of the beam, and sometimes or most of the times it is not given in our in the start of our analysis. Okay, kasi at the start of a analysis before the design is there are a lot of unknowns. Okay, so sometimes a section is not given, so therefore the moment of inertia is given kasi moment of inertia is dependent sa given section or given size ng beam. Okay, so when I is not given, we give it a value of, or we leave it blank, or sometimes if it is constant, we can give it a value of 1. Kasi in the upcoming computations, magka-cancel out din naman yung variable na I. Okay, so we can just give it a value of 1 if I is constant. Okay, so in this case, let me leave it blank. Okay, the next row is L, or the length of the member. So row 5 na to. Row 4 is for the L. So what is row for L? L stands for the length of the member. Length of member. So that is, we just look up ano yung length ng bawat member. So for member AB, so its length is from A to B, that is 5 meters. So we give a value of 5 meters. Okay? Or just 5 na lang para malinis tingnan. And then member BA is basically the same as AB, so it is also, so from B to A, that is also 5. And then next, member BC, that is 7 meters in length. Okay, and from C to B, that is also 7. Okay, so we have fill up L. Okay, next is K. So what is K? Yun yung row 5, yun yung stiffness of the beam. So what is the stiffness of the beam defined? So it is given by the formula for EI over L. Okay, so let me write it here. K is for EI over L. This is absolute stiffness. So based on this definition, we can relate that the stiffness of a member, okay, for EI over L is dependent on 3 parameters, that is E, that is I, and L. So it is, on the numerator side, you have E and I. So it means that the stiffness of the beam increases, nag-increase siya, o tumataas siya, when E and I increases. Ibig sabihin ng E and I, so E is the modulus of elasticity, or that is dependent on what type of material you have used, and I is dependent on the moment of inertia, or kung gaano kalaki yung size ng beam mo. Okay? So, I don't have a beam type of model here in my room. Okay, so let's just imagine this pen and this box. Okay, so For example, my hand is the connection point. Okay, so di nakita. And so it is ito. So as you can see, at the connection point, no, the stiffness of the beam is dependent with E and I and M. So if we compare which of the two members that are connected with each other, such as this uh, box and this pen, okay, sino sa kanila yung mas stiff? Ito. Bakit? Because it has a stronger material, that is E, and it has a bigger section because uh, it it has a bigger eye since it has a larger section. This pen is has less stiffness because it has less E, or that means weaker material is used, and I is smaller, no? Or yung moment of inertia niya is smaller dahil maliit yung section niya. Okay? And then as you can see sa denominator side, you have L. So, L, that is the length of the number. So, as you can see, it is in the denominator. Ibig sabihin, habang tumataas yung L, or while L increases, or the length increases, the stiffness goes down. So, habang tumataas yung L, yung stiffness is bumababa. So, pwede natin tingnan na lang yung example natin dito. Okay, if E and I are constant, okay, ibig sabihin pare-pares yung E and I ng ating example. No, it is the same material, it has the same section. Pinagkaiba lang nila is L. Okay, as you can see, that yung isa mas mahaba, yung isa mas maikli. So, which of one is stiff, more stiff between these two? As you can see, mas stiff si AB kasi it has smaller L, or mas maliit yung length niya. And then si BC is more or less stiff, or parang papunta na siya sa wobbly phase, no? Yung lumalambot na siya dahil lumalaki yung length. Okay, so you can compare this with natural or basic physical examples, such as compare a small ruler to a long ruler, no? Kung sino yung mas malambot. Okay? As makita mo doon na habang tumataas yung L, mas lumalambot yung ruler mo. Okay, so let's determine K. So what is K? Okay, so since E and I are not given, when E and I are not given, we can use the relative stiffness, or the relative K. It is represented by small k. Okay, this one. It is I over L. Okay. Or this is when E is constant. Ibig sabihin same material. But if I is also constant, we can use a simpler form, which is 1 over L. Okay? Kasi magka-cancel din naman yung I sa computation natin. So, if we compute, this is equal to 1 over 5. Okay, since I is constant, we can assign I as 1. Okay, so that's 1 over 5 This one is 1 over 7 and 1 over 7. Okay, I have computed this here, banda dito. So let me just look here. So that is for AB, the stiffness of member AB. Okay, the stiffness of member AB. Stiffness of member AB, that is 1 over 5, which is equals to 0.2. So let me erase 1 over 5 and replace it with 0.2. And then BA is the same, 0.2. And then 1 over 7, that is equals to this one, 0.143. Okay, so those are the stiffness. Okay, so we have filled it up. Next is, what is DF? DF stands for distribution factor. Okay. So what is distribution factor? So let me go back to the PowerPoint. So the distribution factor is defined as K over summation of K. Okay, so we have already defined what is K. So let's define what is summation of K. Summation of K, if K is member stiffness, summation K is often called as joint stiffness, or gaano ka stiff yung isang joint or yung connection point. Okay, so the joint stiffness is dependent to the things that are connected with it. Okay, so an example of that is, sabihin natin meron tayong poste dito. Ayan. Sabihin natin ito yung frame natin. So this joint, ito yung joint mo yan. Itong connection point natin, itong region na to. Dito naman, itong region na to. So how much is the joint? Paano natin na-determine gaano ka-stiff yung joint? I-determine natin gaano ka-stiff yung joint based sa mga nakakonect sa kanya. If, sabihin natin, this one is stiff, this one is less stiff, okay, and then this one is manipis na poste, okay, ito lang yung malaking section, itong beam na to. Pagdating dito, yung beam na to connected dito, and then mas malaki na poste, malaki yung poste dito, malaki yung poste doon, okay, and then medyo malaking beam doon. So if we compare, sino kaya sa kanila yung mas stiff na joint? And when you say stiff, yung mahirap i-move or mahirap gumalaw na joint. So based sa drawing na to, I think, no, sana mag-agree kayo na mas stiff para sa akin to. Okay? Kasi mas matitibay yung mga nakakonekta sa kanya na member. Kumpara natin dito sa manipis. Yung tatlo. Tatlo yung manipis, ito. Dito naman, tatlo yung makapal. Tapos isa yung manipis. So, I think this one is stronger joint. So, based on, it has a large K. No? Dito is smaller summation K. Okay, so summation K is yung joint stiffness. And we can determine that by just adding the stiffness of all the members connected with it. So, pag-add lang natin lahat ng stiffness ng members na connected sa kanya. For example, ito, na-determine mo na yung stiffness ng bawat member na to. Ipag-add mo lang lahat, yun yung magiging stiffness ng member natin, ay ng joint natin. Okay? So, we can easily do that. Okay? So, summation K. I will use another part na lang. Dito na lang. So, for joint A, summation K. So, ano yung mga connected sa joint A? So, una is si member AB, alam natin, which has a stiffness of 0.2. And sino pa? Si pin. There's a pin connection at A. Okay? But, si pin connection is usually given a value of, hindi ko nalagay sa PowerPoint or nalagay ko banda dito na sa dulo. Okay? Okay, for pin, we give it a value of 0. Okay? Let me write it here. We give it a value of 0. So that is yung connected sa A, summation KA. That is the member which is has a stiffness of 0.2 and yung pin which is 0. Ito yung pin, ito yung member. Okay? That is also the same with a roller. But sa pin and roller, they give a stiffness equal to 0. So, summation KA is equals to 0.2. Next, in B, so we can see na yung mga connected sa joint B is member BA, member BC, and the roller. So, that is KBC plus KCB plus K the roller. KBC is 0.2, KCB is 0.143, the K of roller is 0. So that is equals to, parang malaki yung, that is equals to 0.343. Okay? And then for summation KC, okay? So yung connected sa C, as you can see, is you have a fixed support and the member CB. So the member CB plus the K of fixed. When it is a fixed support, we give it a value of infinity. That just means that a fixed support is assumed to be infinitely, no? Is assumed to be infinitely stiff. Okay? Or it is very stiff na we just give it or assume it a value of infinity. So if KCB is 0.143, this one, it is 0.143 plus infinity. We know that any number plus infinity is infinity. Okay, so we have summation KC equals to infinity. Now, the distribution factor is defined as K over summation of K. So if we will assign a value for each member, DFAB, that is KAB over summation KA, okay, and then DFBA, that is KBA, and KBA is connected with summation or connected with joint B, so in denominator is summation KB, and the FBC is KBC over, it is also connected with, no? BC is also connected with joint B, so yung sa denominator is KB. So, basta kung ano yung joint na, kung saan siya joint na nakakonect, yun yung denominator. Okay? For DFCB, that is KCB over summation KC. Okay? So, substitute lang natin mga values dito. Nakuha na natin. Okay? So, I have pre-computed everything naman. So, let me just copy the answers. For DFAB, that is KAB over summation KA. KAB is 0.2. Summation KA is also 0.2. So, that is 1. KBA, that is equals to KBA natin is 0.2 over summation KB, which is summation KB is 0.343. So that is equals to 0.583. Okay, and then the FBC, that is KBC over summation KB, that is equals to 0.143 over 0.343 yung summation KB natin. So that is equals to 0.417. And then KCB over summation KC. KCB is 0.143. Okay? 0.143 divided by summation KC, which is summation KC is equals to infinity. So anything divided by infinity reaches a limit equals to 0. So we assign it a value of 0. Okay, so ganito lang yan, no? Para madali, para hindi mo na inaano, para mas mapabilis, lagi naman mangyayari to. Sa mga dulo-dulo na joints, ito yung mga dulo-dulo na joints, yung A at C, titignan mo lang ano yung type of support. Kapag yung type of support mo is pin and a roller, you will assign that joint or that member that is connected, the distribution factor of the member connected with that joint, give it a value of 1 kung pin and a roller. Okay, kapag naman fix, okay, you give it a value of 0. That is automatically, ganun yung lagi mong makakompute if gusto mong i-bypass yung computation. Okay? And then also, para ma-check mo, if you add these two, which is the members that are connected with this joint, okay, si BA, which is at this part, and then si BC, which is at this part, if you add them, the distribution factor, dapat makuha mo yung value na 1. 0.580 plus 0.417 is equals to 1. Okay, so lagi yon sa joint. So what does distribution factor mean? So distribution factor just means na how much of the moment will be transferred to each member. Okay? So, ganito lang siya. For example, there is an applied moment here. Okay? At this joint. So, apply ditong moment na to sa joint na to. Sabihin natin MB. So, tatanungin lang sa problem, how much of that moment will be transferred to the other member? Okay? So, gaano karami yung iproproduce or mare-receive na moment or mare-receive na moment ng member na to versus yung member na to. So, depende yan sa distribution factor. Okay? So, ganito lang yan. Mas malaki na stiffness or mas stiff yung member na yon, mas marami siyang tatanggapin na moment. Kapag less stiff, mas konti yung moment na tatanggapin niya. Okay? So, as you can see naman sa computation na to, 0.583 yung tatanggapin ni BA, or that is 58.3% of the moment applied will be transferred to BA. And then 0.417, that is 41.7% of the moment applied at joint B will be transferred to joint or to member BC. So, ganun lang yung interpretation ng DF. Rewrite this. Okay? So, ayan. And then we go to the next part, which is this one is for our fixed end moments. So, what are fixed end moments? So, let's just go through this again. Fixed end moments are the moments that are produced when you have two fixed supports on a single member. So, yun yung mga moments na maproproduce for such cases. Okay? So, fixed end moments are usually given by formulas. Okay? Usually, kapag bumili ka ng mga books ng structural analysis, nasa pinakalikod na page sila. Okay, so ito lang. So, there are a lot of cases, but we will mostly use these three cases pala, I mean. So, you have WL squared over 12. Okay, for the fixed end moment that is occurring at this joint A na to. Okay, at this one. And it is counterclockwise. I think I have put it here. Ayan, para mas masulatan ko. So, ito yan, FEMAB is this one. It is counterclockwise, so pwede natin lagyan ng negative signs. Okay? Ito naman is FEMBA. And we usually give it that direction, which is clockwise. So, that is WL squared over 12. Okay, W is the intensity of the distribution. L is the length of the member. Okay, this is for the case of a uniformly distributed load that is spanning from the whole member, in the whole member. Next naman, if you have a concentrated force at any point, no, we usually Ganun pa rin yung assume natin na directions for AB and BA. AB just means the left end moment, and BA just means the right end moment in this context. Okay, so that is negative since counterclockwise siya. Okay, so P is the value of P is when it is given. A is the distance from the left end to the right end of the concentrated force, and B is the right distance from the concentrated force to the right end. So that is, madali lang tandaan to, that is PB squared A over L squared. Okay, laging naka-squared yung L. And then, itong squared na to, magbabaligtad lang yan. Okay, kapag kinuha mo yung sa right end, mapupunta sa A yung squared. No? As you can see here. Yan. So, yung squared na to, malilipat lang sa A pagdating dito. Ayan. So, madali lang tandaan yan. And then, for a distributed load that is not occurring or it is not spanning throughout the full span of the beam member, so usually we give this formula. We assign this formula. So that is W times D. D is just the length of distribution, gaano kahaba yung distribution, and then over L squared. L is the length of the beam pa rin, or the length of the member. And then A, yun nga, parang doon sa concentrated force, that is from the left. Dito naman, since distributed siya, uniformly distributed, kukunin lang natin from the left hanggang doon sa gitna. Dito naman, yung B from yung gitna hanggang doon sa right end. Okay? So, lagi sa gitna. Kasi, doon yung, di ba kapag kinukuha natin yung area ng distribution, we assign it a value na yung concentrated force, equivalent concentrated force niya, will occur at the center or at the centroid of the distribution. Okay, so yan yung formula. Madali lang tandaan din to. That's WD over L squared. Lagi, nandyan yan. Times the quantity AB squared plus the quantity of A minus 2B times D squared over 12. Laging nandun din yan. Tsaka to. Okay, tapos ito, itong A tsaka B, magpapalit lang yan ng pwesto. No? Itong B, pagdating sa right end, to, pagdating dito, that is A, yung magiging squared. Okay, dito yung B. Tapos, yun nga, magpapalit lang ng pwesto yung A tsaka B. No? Tapos yung D squared 12 mananatili tsaka itong expression na to. So, madali lang yan tandaan. Okay? Okay, so I have pre-computed the FEMs. So, assume lang natin, since wala tayong fixed N dito, so, ang process ng moment distribution kasi, pinapagawa niya is you assume first that the members are fixed-ended, no? Kapag fixed-ended dyan, magkahiwalay na sila. Nag-terminate na sila. Okay, so yun yung gagawin natin. Pinapa-assume sa atin if it is na-fix yung bawat member sa dulo, sa bawat N nila, sa bawat member N. Okay, if nangyari yon, we should apply the formula of fixed end moments. Okay. So ito, I have solved the fixed end moments. So dito, dalawa yung case natin. We have a distribution So we will apply not this one since hindi naman siya buo, but this one which is a more general. Okay, so we will apply that formula plus this concentrated will also produce a fixed end moment at that part or at that member. So if we consider member AB, so for member AB, if we assume it as fixed, meron tayong distributed load dito. Yung D is this one. Okay? So D is equals to 4 meters. The W is 17. Okay, the length of the beam member is 5 meters. Okay, and then we measure A and B. So, saan natin measure yung A and B? Sa gitna nito. So, yung hatiin lang natin ito. So, 2 meters, 2 meters. So, in this case, for this case, yung W natin is 17. Yung A natin is 2 meters. Yung B natin is equals to 2 meters plus 2 meters plus 1, that is 3 meters. Ayan. And then L is 5 meters. So if we compute all of that, makuha natin, based from this load pa lang, is, ito na, kinompute ko na, substitute lang dun sa formula, substitute lang sa formula na to. Okay, substitute lang natin dito. And then we just give it a negative sign para indicate na counterclockwise. So, kasubstitute natin may makuha tayong value na negative 34.453 kilonewton meter. But that is from this load pa lang. Let me draw another. Mas malinis. Should have put it red. So, yung negative 34.453 is produced by the red distribution. 453. So, since counterclockwise na siya, no, naka-represent naman na counterclockwise, kaya inalis ko muna yung negative. And then, since meron pa nag-occur na ibang load, which is si P, okay, so kailangan din natin kunin kung ano yung magiging fixed end moment on this span or yung kanyang contribution sa fixed end moment. So, mawawala. Okay. So, tingnan lang natin si concentrated. So, based dun sa formula, that is PB squared A over L squared. Lagyan din natin yung negative sign since it is counterclockwise. So A is 4, B is 1 for the 25. Okay? So if we compute that, I have it here. No? Produced by the concentrated force. So that is PAB squared over L squared na putol lang. Pero substituting, that is nalalagyan lang natin ng negative sign. 25 kilonewton yung ating force concentrated, and A natin is 4, B natin is 1. So that is PAB squared over L squared or PB squared A, di ba? So pares lang naman yung PAB squared at PB squared A over L squared, that is 5 squared. So nakuha doon is negative 4 kilonewton meter. So yung negative 4 na yon is produced by the concentrated. Okay? So yun yung nangyari. So if lilinawin natin, if we consider the whole, effect of these two loads, so yun yung magiging FEM-AB natin. FEM-AB natin is yung combination na to. Okay, so pag-add lang natin sila, that is 34.453 plus 4, that is 38.453. Okay, it is negative, ibig sabihin counterclockwise. And ganun din yung gagawin natin dun sa left. Okay, so we compute. Okay, so substitute lang. Again, magpapalit lang yung pwesto ng squared natin dito. Tsaka yung, magbabago lang yung, magpapalit lang ng pwesto yung B tsaka A. Kung papansinin natin. Nagpalit lang sila ng pwesto. Okay, so compute lang natin. Na-compute na siya din dito. So, that is 29.013. 29.013. And dun naman yung contribution ni concentrated na compute natin. So PA squared B na siya. Now yung nagkaroon na ng squared is si A over L squared, that is C 16. So pag-add lang natin yon, 29.013 plus 16, that is FEM BA. So that is equals to 45.013. Okay, so pag na-compute na natin yan, we can transfer it to our table. So that is negative 38.453 and 45.013. And we do the same with member B, C, and CB. So member B, C, and CB, okay, isa lang naman yung nag-act, which is 35. So apply lang natin yung formula for the concentrated force. Ito lang. Okay, so kapag na-compute na natin yon, pares lang naman yung process. Titignan mo lang yung A tsaka B pa rin. Yung A or yung small a tsaka yung small b. Small a in this context means yung distance niya from the concentrated hanggang sa left end of the member, and yung B is from the concentrated hanggang dun sa right end ng member. So pag na-compute na natin yon, which is na-compute ko na dito, So, abot pala ng isang oras, no? FEM BC, that is equals to negative 14.286. Negative indicates na counterclockwise siya. And then 35.714. Okay, so the next step, so those are uh, the the important steps, no, before we do the distribution process. Okay, so we are in the distribution process na. So for our first distribution, okay, so first cycle of moment distribution is this row right here. So gagawin lang natin is for the first distribution, we just sum the moments acting in the joint. Okay? Kasi this one, and this one, yan yung mga moments na nag-act sa joint natin ngayon. Okay? So si negative 38 nandito. Tapos si 45 nandito. Si negative 14 nandito. And then 35 nandito. Ayan. So, kailangan lang natin i-distribute itong mga moments na to. Okay? So, una, kailangan natin gawin is, for example, this one, no? We just sum every moment at acting at the joint. So, kung mag-isa lang siya, siya lang siya. Kung mag-isa lang siya, wala ka nang isa-sum. No? Just copy-paste. So, mangyari is, kailangan lang natin mag-apply ng negative sign. Okay? So, sabi, multiply the DF of the corresponding member with a negative times the moment at the joint to get the first cycle of distribution. So, for example, erase ko lang to. That is negative 38.413. So, you just apply a negative sign and then multiply it by negative 38.453, since the sum of the moment acting at joint A is just negative 38.4153. So the answer will become negative times negative, magiging positive 38.453. And then at joint B, what ba may sa labas. And then sana hindi dinig yung, hindi ko alam kung motor yon or sasakyan. Okay, sa joint B, there are two moments acting at joint B, which is this one and this one. So, kailangan lang natin i-add. So, i-add lang natin ito. So, that is, again, we apply a negative sign before we add. So, that is 45.013 plus, since negative yon, plus minus 14.286. Okay? And then we multiply it by the distribution factor. Ito pala, nalimutan ko multiply ng distribution factor. So mag-multiply tayo ng distribution factor niya, which is 1. That is 38.453 times 1, which is the same, 38.453. And this one, multiply natin is times 0.4583. Okay, so yung makuha natin answer doon, let me look at the ano nakuha natin answer. Let me just repeat the process dito. That is equals to negative 17.914. So, makuha natin answer dito. It's negative 17.914. Again, the same process pa rin. We sum the moments acting at the joint. Okay, so we're still at joint B. Okay, so yung mga moments na nag-act sa joint B is still this one. So that is the same, almost the same solution, negative plus 45.013 minus 14.286. Ang kaso magbabago is yung multiply natin distribution factor, which is 0.417. So multiply that by 0.417, we will get the answer. I will just refer to my pre-computed. That is equals to negative 12.81. Okay. And then lastly, this one. This is negative 35 or negative times 35.714 times 0. Okay, so anything multiplied by 0 is 0 kasi 0 is its distribution factor. Okay, so 0. Okay, so I hope nakasunod. Next is the carryover moment line. So what are carryover moments? So carryover moments are the moments that will be, the name suggests, will be carried over at the other end of the member. So for example, let me erase this one. Okay, so the moment acting at this joint and at this joint, okay, let me give them, okay, itong moment na to will be felt also at the other end, and sinasuggest na moment distribution, it is 1/2 of whatever this is. Okay, so ganun din ito. Kung naramdaman ni joint B si MB, mararamdaman ng konti si joint A, mararamdaman ng konti ni joint A yung MB, which is kalahati lang ni MB. So, ganun yung carryover moment. So, kailangan lang natin gawin is yon, carryover moment. So, we just, ano ba yung mga members na magke-carry with each other? Una is yung AB and BA, and then yung BC tsaka CB. Okay? So, palaging ganon. Yung parehas na members, doon lang tayo magka-carry over. Hindi ka pwede mag-carry over ng BA papuntang BC. Kailangan mag-carry over ka BA papuntang AB and AB papuntang BA. Yung BC papuntang CB, yung CB papuntang BC. So, how do we do that? We just divide this by 2. So, una, carry over natin siya on that side. So, we divide this by 2. That is 38.453 divided by 2. Okay? And ito naman, ganun din, carry over natin sa kabila. That is negative 17.914 divided by 2. Okay? Ito naman, carry over siya doon. So that's negative 12.813 divided by 2. This one, 0 divided by 2. And then we do the computations. If we do the computations, makuha natin answer dyan is, let me refer ulit dun sa na-compute ko na. that is negative 8.96 or 957. This one is 19.27. 38.453 divided by 2. 0 divided by 2 is 0. Negative 12.813 divided by 2 is negative 6.407. Excuse me. Okay? So the next part is just repeat what we have done on this part. Okay, we will just repeat the process of first distribution. Okay? So, paano ulit? So, itong mga na-carry over, yan na yung titingnan natin. Kailangan natin ulit i-distribute itong mga na-carry over. Okay? So, kailangan natin silang i-distribute. Paano ulit tayo nagdi-distribute? So, balikan natin yung step na yon. Okay? Okay, multiply the distribution of factor of the corresponding member with a negative times the moment at the joint to get the first cycle of distribution. So the moment of the joint at joint A, no, after we carry over, so kailangan natin i-distribute ito. Okay? So negative 8.957 is what occurs at the joint. So that is negative 8.957 times negative times negative 8.957 times the distribution factor 1. Okay? So we just repeat the process. No, parang tatrato natin kung ano yung ginawa natin sa part na to. Okay? Sa part na to, gawin natin, no, nung kinukuha kasi natin first distribution is kino-consider natin yung sa taas niya. So, nung kukunin natin second distribution, consider mo lang yung sa taas niya. Okay? Para hindi ka nalilito. So, that is equals to 8.957 dito. So, ipag-add lang natin ito. So, that is 19. So, kailangan natin mag-multiply na negative. That is negative times the sum of 19.227 plus 0 times the distribution factor which is 0.583. Okay? So, may makuha tayong sagot doon. Makuha natin sagot doon. Is saan? Ayan. Nakuha natin sagot is negative 11.209. And then, ganun din naman, ulitin natin. I-add mo itong dalawa kasi nag-occur sila sa joint B. Mag-multiply ka ng negative, tapos multiply mo sa distribution factor. Makuha mo sagot is negative 8.017. Okay? Ito lang naman yung nag-occur sa joint C. Okay? Kailangan natin siyang distribute. So, negative times negative 6.407 times the distribution factor na 0. So, magiging 0 lang yun. Okay? And then, the carryover moment, ganun pa rin. We divide this by 2. Carryover natin doon. Ito doon. So, 8.957 divided by 2, that is equals to 4.479. Negative 11.209, that is negative 5.605. Okay, 0 divided by 2 is 0. Negative 8.017, that's negative 4.009. So we repeat the process again sa third distribution. So again, kung kukunin mo to, titingnan mo lang yung sa taas niya. Okay? Para makuha mo to, kunin mo to, multiply mo na negative times yung distribution factor. Okay? Tapos pagdating dito, since sa joint B, dalawa yung moments mo, i-add mo yan, 4.479 and 0, i-multiply mo na negative yung nakuha mong sum doon, times mo sa distribution factor. Yun yung makuha mo dito. And again, you do that the same, 4.479 plus 0 times negative times 0.417, yun yung makuha mo dito. And ganun yung dito, isa lang na moment yan, so that is negative 4.009 times negative times 0, yun yung makuha mo dun. Okay, so you repeat the process until you will reach the fifth distribution. Okay? Mostly, ginagawa ito kapag ginagawa mo sa paper, hindi mo na sinusulat yung bawat computation mo. Dinediretso mo na siya sa calculator natin. Okay? Ayan. Dinediretso na natin siya sa calculator natin. Yung mga process niya. Kasi ulit-ulit lang naman yung process kapag mano-mano natin. Okay? And then, after that, sabihin natin alam na natin lahat yan. Gagawin natin is from the FEM part, from the FEM hanggang dun sa last distribution, which is usually recommended fifth distribution, ipag-add lang natin lahat ng numbers doon on that column. Yun yung makuha nating final moment sa M AB. Kasi we are at the member AB. And then, ganun din dito, from FEM hanggang dun sa fifth distribution, ipag-add lang natin. Yun yung final MBA. Okay? So, pag-add lang lahat natin ng numbers na makita natin. Ganun din dito, yun yung final MBC. And then final MCB, which will give us these answers. Okay? As you can see, let me just write na lang yung final moments. As you can see, that is 0. That is 38.4. 425. Negative 38.425. And 23.78. As you can see, as expected, since this is a pin support, now the final moment at the pin support or a roller support, yung dulo, if the end is a pin or a roller, the final moment should be expected to have a value of 0 since no moment will be transferred to a pin support. Okay, ayan at joint B, ano yung moment niya? Dapat 0 din. Check natin. Kasi roller yan. So, check natin. Ito yung mga moments na mag-occur or yung final moments na mag-occur sa ating joint B. That is 38.424 and negative 38.424 din. So, that is equals to 0 if i-add natin tong dalawang to. So, magbabalance siya. So, ibig sabihin at the roller, 0 din yung moment natin. And then, this one, it has a value since at the fix, it is expected that a moment will be transferred to the fixed support. So that is 23.78. Okay? So that is the steps in the moment distribution process. Okay? So ngayon, di pa tapos yan dahil we still have to find the reaction. So how do we do that? We just do a section analysis. Kaso, unlike before na yung section analysis natin, di ba, is magpuputol tayo ng a certain section at a given x distance, for example, dito, and then we give it a value unknown x. Ngayon, hindi na natin gagawin yon. We just do a section analysis per span. So, ibig sabihin, since per span na siya, alam na natin yung length, which is buo na siya, 4 plus 1, that's 5. Dito is 5 plus 2, that is 7. And then we reflect these final moments. These final moments reflect the internal moments. Okay? So if we do a section analysis, we dismember the beam. Mapuputulin natin yung beam. So ito yung joint A, saktong joint B, and then saktong joint B hanggang joint C. So ito indicates yung moment sa AB. So MAB is 0. Okay, this one indicates BA. So that is positive 38.424, ibig sabihin clockwise moment. So MBA 38.424, MBA 38.424, and then MBC that is equals to negative 38.424, kaya dinawin ko siyang counterclockwise. Okay, so the negative indicates yung direction na counterclockwise, and then positive sabihin clockwise. Okay, so that is our section analysis, and then yung mga load siyempre reflect natin. Oops. So merong distributed load equals to 17 kilonewton per meter, and then merong concentrated force na 25 kilonewton. This has a length of 4 and then 1. Four meters, 1 meter. And then, siyempre, if you're doing a section analysis, you're also analyzing the shear forces acting at the beam. So that's VAB and then VBA. Okay, so inano lang natin, minamatch lang natin kung ano yung kapartner niyang moment. So kung MAB, VAB. Okay, dito naman, you have 35 kilonewton. And then, dito meron kang V, BC, BCB. So the next step is you just analyze or solve for the shear forces. So, wala pa palang length to. This is I think 5 and 2. 5 meters and 2 meters. So, do we solve for the shear forces? So, how do we do that? So, para ka lang kumukuha ng reaction, no? Para ka lang kumukuha ng reaction, para isipin mo na ang reaction to, para makuha mo to, titingnan mo lang yung point na to, hindi to lilitaw sa equation mo, and then you solve. Okay, so sample lang natin. Sige. So VAB, no, that is equals to 17 times 4, no? Tinitingnan natin, pag kukunin natin to, dito tayo titingin. 17 times 4 times yung distance ng gitna ng 17 load na yon, pumunta doon, that is 2 plus 1, tama? That is 3 meters plus 25 times 1. Kasi, again, tinitingnan natin, pares lang naman sila ng direction. Okay, so, lahat sila mag-rotate in a counterclockwise. So, ibig sabihin, i-add din natin dito yung MAB, kaso 0 na siya. Pero sulat natin, minus 38.424 all over yung distance ni A papunta sa B, that is 5 meters. So, laging ganun. Para lang tayo nag-review ng paano i-solve yung reaction. Ganun din naman yung process ng pag-solve ng shear forces at the joints. Okay, these are the shear forces at the joints kasi. So, parang itrato mo lang silang mga reaction. So, you do that. We do that. Okay, so yan yung solution. Okay, so ito. And then, after natin ma-solve lahat ng mga shear forces, we can now solve yung mga vertical reactions natin. Just note that the reaction force is the combination of the shear forces at the joint. So, for example, the reaction at joint A is just yung shear force na nag-act sa joint A, which is VAB lang. And then, reaction at B, at joint B, is the combination of the shear forces acting at joint B. So, ano yung mga shear forces na nag-act sa joint B? VBA and si VBC. Okay? So, they are both acting at joint B kasi. And then, reaction C, that is VCB. Kasi VCB, yun lang yung mag-act sa joint C. What if meron pa dito? For example lang na meron pa tayong CD. So, meron tayong VCD dito, VDC dito, MCD dito, MDC dito. Pag ganun, ano ba yung mga, yung RC mo nun is hindi lang VCB, kundi VCB plus VCD. Kasi may shear force ka na nag-act or meron na another na nag-act sa joint C, which is si VCD. If meron mang ganong scenario. So, in this case, 2 span lang siya. So, hanggang doon lang tayo. So, that is the end of the process. actually. So, ito na yung mga reaction forces natin, which is ito, na-solve na. Okay, so the next step is draw a shear and moment diagram, which is, hindi ko yata nalagay dito yung shear and moment diagram, but I will send it to you na. Shear diagram lang yung nalagay ko, sorry, sa PowerPoint na to. Anyway, that is for our lesson. So, bandang dulo, sa bandang dulo ng process sa pagkuha ng shear forces, or pag section analysis ka na, wala nang panibagong konsepto sa inyo. Lahat ito is na-discuss na. Yung panibago lang is itong table na to. Pero pagdating dito, you can do that, and then hanggang shear and moment diagram. Okay? So, marunong na kayong gumawa niyan. Kasi kung di-discuss ko isa-isa ulit yung mga ito, baka umabot ng 2.5 hours.